D.2, overflow problem in project 1. In this video, I want to explain the overflow problem and how do we solve it. All right. Yeah, so for this problem, when we apply our first bad algorithm, straightforward recursive algorithm, you just use our notes. Module 3, part B.4, page 2. The pseudocode is there. Just use that one. Yeah. So you can easily write a program. Yeah. But when you do the test, here I want to give you, what do we need to have? Okay, yeah. So you can feel how bad it is. Yeah. I do not want to take too much time on it. Yeah. So I use this criteria. What is the largest Fibonacci number you can find using that bad algorithm within 1 minute? 60 seconds. 60 seconds. 1 minute. Yeah. So you can control your execution time after you hit enter button. Your program do the calculation. Yeah. All right. Yeah. You just wait there. Okay. Yeah. You do experiments. Fibonacci number on the what n you can, what is the largest n? F of n, right? F sub n you can get within 60 seconds. Now, based on my experiment, my n approximately 50. Yeah. Approximately. Yeah. It depends on your computer. Yeah. My computer laptop, not a powerful one. Yeah. Just so I can do it within 50. Oh, I can find f of 50. Yeah. Around, yeah, probably plus minus some numbers, near 50. Okay? Yeah. Up or down, approximately that number. So your computer, if your computer very old, then you get a 40 something. If your computer is very fast, powerful, you can do a little more. Yeah. But it cannot be too much more than that. Yeah. So here you can see how bad is the algorithm. Because 60 seconds for a computer, it is a long time, right? Even you sit there for 60 seconds, you feel like a century. So long, right? How can I wait here for 60 seconds? So you will feel it. Okay, yeah. So that's for our bad algorithm, the first one. Yeah. So you get that slow impression. Yeah. Then we move to good one. Yeah. But when we move to good one, we need to carefully control that overflow problem. If you cannot control overflow problem, even you can find your answer very fast, but it's a wrong answer. As I explained in the previous video, when you get an overflow, you don't have error message. Nobody knows if it's correct or not. Nobody knows that because your number truncated. Okay? No complaint from your computer, but it is wrong. Okay? Yeah, we don't like to see that happen. Yeah. All right, so in Java, the first step, we can reduce this overflow issue, not eliminate, reduce it. We use the long integer type. Do not use the integer int type. If you use int type, only 62 bits. Each int use 32 bits. 32 bits, not 62. 32 bits. But if you use long integer, how many bits? 64 bits. That's quite a lot. 64 bits. Okay? So that is 2 to the 64th power. How large is that number? Okay? Yeah. So you can calculate more Fibonacci numbers, but there is a limit, right? Sooner or later, you will get an overflow. Yeah. But you need to find a way to detect. How to find a way to detect the overflow? You need to find a way to detect. Okay? Yeah. So that's part of our project. Overflow detection. Overflow detection. How to do overflow detection? That's part of our project. Project 1. You need to do it. Yeah. So in my next video, video D.3, I want to talk about overflow detection a little bit. Okay? Yeah. So there are 2 different ways to do it. Yeah. So you can determine which way you like. Yeah. 2 different ways to determine overflow detection. Yeah. Probably I may like you to try both ways for this project. You try both ways. Yeah. And see if you get the same answer. Yeah. So that's the video D.3 topic. Yeah. All right. So here, I want to tell you, so based on my experiment result, okay, if I use the long integer, I can go f of n. How large is this n? N equals 90 something. 90 something. Okay, less than 100, 90 something. A little more than 90. That's what I get. Okay? Yeah. That's what I get. Okay? Still not a big number, right? Only 90 something, less than 100. To use this number, 64-bit long integer we feel pretty big, but we cannot do too much. Less than 100 for the Fibonacci number, right? Yeah. All right. Next, we want to find a better solution to completely solve this problem. The challenge question. How to calculate Fibonacci of 10,000. Not just 100, 10,000. How much bigger? You can see, yeah. So definitely, we need much better, powerful way to store our data, to store the values of our integer variables when we calculate the Fibonacci numbers. How big it? Yeah, this big. Okay, yeah. So it's the challenge, but here I give you the solution. The solution is very simple. Yeah, solution is in Java. Here I talk about Java. Okay, yeah. The big integer data type. You just use the big integer data type. There is one class called a big integer. If you use that, you can handle that overflow problem. You can handle that overflow problem nicely. Yeah. So here we need to learn about this big integer. Yeah. Why it can solve that overflow problem? Because it uses strings as the underlying implementation data structure. Strings. So you represent long digits, thousands of here, 10,000 digits, 10,000 digits, but your Fibonacci number even much bigger than that, right? Yeah, multiple, yeah, so huge number. You can imagine, right? Yeah. So how can big integer store such a big number? Because it uses string, represent the digits, long digit as a string. What is the limit for a string? There is no limit, right? So that's why. So we can use string to represent big integer without overflow. Yeah. But Java does the operation. To handle the operation, you need to do a lot of work. Yeah. Java does that. We just use it. We don't need to do anything. We just use it. Yeah. But how to use this class? That's another issue. You need to get familiar with how to use this class. Yeah. I give you one example. I post one example. So to save your time, although you can find examples from web. Yeah, you can find many examples in the web. Yeah. Here, I just give you my example. I create an example using big integer to do some operations. Here, what I do square root operation. Yeah. So in my program, I generate 100. Why so slow? Yeah, 100 digits. Yeah. Yeah, the reason slow because I'm doing video. The software make it response time very slow. 100 digits random integer. How big is that? 100 digits. Can you imagine how big is that? Yeah. So I create a 100 digit random number, integer. Okay. Then I take square root of it. Take square. Suppose x is this. This is x. Then I take square root. The calculation. So I create my own algorithm to do the calculation. Remember that for the square root, I cannot do, the fractional way square root. I can only use the integer multiplication, try to approximate. Yeah. So yeah, when you look at my algorithm, it's pretty long. Yeah, but you try to understand it. Yeah. All right. So I calculate, but because I need an integer, so I calculate the ceiling function of the square root. Okay. So because it must be an integer, the program must return an integer. All right. Yeah. So then, because this number, its square is greater than original x, right? Yeah. Because I do the ceiling function. It is larger than the real square root. So after you take square, it is greater than x. Then I have another one. I take the floor function. So it is square less than that. Okay? Then I do the difference. Take the difference of this is my difference 1, and the difference, this is my difference 2. Then I also show these two difference numbers. The purpose just let you see how do I do big integer operations in this example. That's the thing I want to show you. Okay? All right. But when you use big integers in your program, you only do addition and subtraction. Fibonacci number, you only plus, minus, right? You only need to do that operation. So much easier than my example. Yeah. All right, so let me run my example to show you a little bit. Yeah. Oh, by the way, regarding how large is this 100-digit number, here I want you to compare with this one. How large is this one? Okay. This one, compare that. This, when I estimate, that is about 20-digit number. 20 digits, this number. But here I create a 100-digit number. So you can see much, much larger than the long integer maximum number the long integer can handle. Okay, all right, yeah. Let me show you my program. Okay, all right, so here is my program. Yeah, I will upload this program so you can download and study. All right, so that's the last time I run this one, but now let me run a new one because I generate a random number every time it generates different number. So you will see the different answer. Run another time. Okay. Yeah. Yeah, so that's my output. Let me show you my output. All right. The first line, original number. So that's the 100-digit big integer. Okay. Second one, I find its square root, estimate. It must be integer, but I take the ceiling function, a little bigger than that, real square root. Then I do difference from above, difference from below. I calculate that. You can see the difference also pretty big. Yeah. My approximation in the square root only a fraction moving up, a fraction moving down, right? But when you do square, the difference is so big. So these are two difference numbers. Yeah. Anyway, yeah. So that's this example. Yeah. So I will post it with this lecture notes. So after you download, you can study. But this is a Java program. Yeah. For some students may like to use Python to do this project. It's okay. Yeah, Python. If you like to use Python, no problem. You can use it. Yeah. But the Python, there is something a little different. Because the Python, there is no overflow thing. Yeah, the Python already handle the data using that big integer way, underlying string way. So no overflow. Yeah, Python already solved that problem. So if you use Python, I may like you to estimate overflow. You still estimate overflow, but you use that 64-bit number estimate. Yeah, you can still do that. Yeah. All right, so let me stop this video, D.2.